Hello and welcome to this video presentation of ZoneZero, Safety's industry-first perimeter access orchestration solution for achieving zero trust the right way. Our agenda today will include three main items. We'll start with an introduction to secure access in the modern environment and the challenges organizations face in today's world of digital transformation. We'll go over the concepts of traditional secure access and their main limitations, especially in legacy environments. We'll then talk about zero trust, different concepts of zero trust, common implementations and challenges, and finally we'll introduce ZoneZero, perimeter access orchestration, the concept and the various solutions. In the old world, the perimeter was clear. We started with an on-premise only environment with no remote access. But very quickly, as technology and business developed and became more global and dispersed, access was extended to include that of remote, unsecure location to a secure and very sensitive location. This includes the access of employees, remote workers, customers, and others. In the modern world, the one that's currently going through a process of digital transformation, we have multiple platforms, tools, teams, and users. This creates a vastly expanded attack surface. There is no single policy, view, or point of enforcement, which means low visibility and low control. The perimeter definition has become vague, and securing it very complicated. Secure access is the term we use when we want to grant access from an unsecure or untrusted location to a secure and trusted one. In this figure, we can see the client in the untrusted location in yellow, and the corporate resources are in the trusted location in gray. Traditionally, the line separating these locations represents a firewall to create network separation. Secure access can be viewed as a process with four main components: authentication, who is the user; authorization, what can the user do; access, providing physical connectivity; and resource, providing access to the actual resource. Let's see how these four components translate in practice to the common use case of VPN. Authentication is performed against a VPN gateway. Traditionally, the user has a username and password, but some VPNs require an additional certificate or token that is matched with Active Directory. Compared to modern authentication technologies available today, this is not considered adequate verification. Authorization is handled by the VPN as well, on the same gateway. How about access? Once the user is authenticated and authorized, the secure network is extended to him. Oftentimes, the secure network is a simple flat network, which means that the user can now access or touch the entire network, whether needed or not. Which finally brings us to the actual resource. That becomes available like everything else on the network. You'll also notice that in this model there is no direct policy enforcement for the various different resources on the network. Unfortunately, this creates a hacker's paradise. Win one, win it all. This slide shows an example of how lack of module separation makes a vulnerability in the VPN a disaster. Since all modules are managed in the VPN itself, a single exploit chain can collapse the entire security posture of the organization. Physical network-based access is both dangerous and overly permissive by nature. Here's one example of how granting physical network access can go wrong. When such access is granted, there is no application-level access control or monitoring. As a result, many protocols can be used and abused to spread through the network. Many ransomware attacks use the SMB protocol to propagate. Vulnerabilities have been published in 2017 for versions 1 and 2 of the SMB protocol, which were followed by newer versions of SMB being released. But these types of threats are not gone. In 2020, two critical vulnerabilities titled SMB Ghost and SMBleed were discovered and published as well. Today, anyone can purchase a WannaCry type ransomware package weaponized to spread via SMB on the darknet. Amazingly, you can even get it today in the model of a software as a service. And make no mistake, this is not unique to SMB. So let's talk about addressing those challenges with zero trust. The concept of zero trust was created to overcome the challenges in secure access. Zero trust is based on three key concepts. The first is trust nothing. Assume that all traffic is threat traffic until determined otherwise, regardless of location or hosting model. Then there's continuous authentication. Ensure all resources are accessed securely, regardless of their own location, the location from which they are accessed, and even if they're on a pre-existing session. And finally, we have least privileged access. We need to strictly enforce access control in a very granular way. The Zero Trust model and concepts are widely accepted in the industry. Major analyst firm Gartner recognizes this and says, Zero Trust network access provides controlled access to resources, reducing the surface area for attack. The isolation afforded by Zero Trust network access improves connectivity, removing the need to directly expose applications to the internet. Enterprise access requirements are growing ever more complex due to the application dynamics, cloud adoption, and mergers. To cut through this complexity, technical professionals should explore software-defined perimeter, a new technology whose strength lies in facilitating access to enterprise applications. When we get to the actual implementation of Zero Trust, most solutions are achieving these concepts through the distribution of modules, specifically separating the data plane from the control plane, improving authentication by the use of MFA, and replacing physical access with application-centric access to improve the separation, monitoring, and control of access. SDP, or Software-Defined Perimeter, is one popular way of achieving Zero Trust. This SDP framework diagram illustrates the separation of the control plane and the data plane, and the application-level access that removes user from the network and prevents lateral movement and the propagation of malware. So SDP solves the problem, right? SDP solutions are revolutionary and excellent. Many of the concepts of Zero Trust are built into them natively, and they can definitely be fast and simple to deploy. Unfortunately, SDP solutions typically support web-based applications and cloud-based access schemes only. When legacy access schemes such as VPN are heavily relied on, migrating them to SDP can prove very challenging. Furthermore, when legacy non-web applications are in use, such as SMB, RDP, Citrix, SFTP, or even mainframe, SDP integration and support are far from trivial. With that in mind, let's take a look at what we get to choose from when we build our security strategy. SDP does not support legacy applications and infrastructure, and anything that isn't natively Zero Trust aware. Additionally, current SDP deployment models are just not scale-ready for large organizations that manage thousands of endpoints and devices, accessing multiple corporate subnets at any given moment. This makes legacy infrastructure a vital part in keeping sensitive and confidential information exchanges secure and private. Then we have VPNs. Many VPNs now offer two-factor authentication, or 2FA. However, classic 2FA is far different from modern MFA and has proven extremely vulnerable. VPNs that are network-centric by nature place users on the network, leaving applications exposed to internet cyber attacks such as the recent wave of malware VPN attacks, bypassing password and 2FA authentication methods. Some organizations try to mitigate that risk by going through a process of network microsegmentation alongside VPN. Not only are these multi-year, tedious, and expensive projects, they also introduce severe operational overhead, require constant maintenance, and quickly become impossible to scale as the organization grows. And finally, we have identity provider-based MFA. While MFA and identity providers have significantly improved the authentication process, the lack of service-centric approach and the significant challenges in integrating them with legacy and proprietary services make it impossible to cover all the resources in the organization. IDP vendors are offering hundreds of MFA apps, APIs, and SDKs for integration, but these force you, assuming you can, to redesign, recode, and redeploy corporate applications, which in most cases lead to project rollback, money lost, and assets still vulnerable and unprotected. To illustrate the challenge further, these are IP port VPN firewall rules that are based on address ranges. 250 service definitions and 472 network definitions. And this is for a company of 100 employees that is actually properly microsegmented and managed. But even if we do that and accept 2FA, we are still very vulnerable. 2FA has been proven to fail proper two-step authentication again and again. Most 2FAs are SMS and phone number based, which makes them susceptible to a variety of attacks such as a SIM swap, SMS interception, automated phishing, and a zombie browser. Recognizing these many challenges in the world of secure access, we'd like to introduce you to Safe-T ZoneZero, Perimeter Access Orchestration. This is an industry-first, holistic operational and security approach for zero-trust network access. Safe-T helps organizations achieve zero-trust strategy initiatives by simplifying the journey to zero-trust. Central management, simple deployment, and seamless integration. Leverage existing secure access technologies and achieve zero trust the right way. ZoneZero revolutionizes the three pillars that stand at the heart of a zero trust strategy: a software-defined perimeter, VPN access, and multi-factor authentication. This is a conceptual scheme of a ZoneZero deployment. At the core of it, you'll notice the separation between access gateway and access controller, the ZoneZero access and data planes, and an authentication gateway that centrally integrates in-house, third-party, or IDP-based MFA. The simple deployment concept places ZoneZero in a traditional DMZ or internet-facing environment between a VPN or firewall gateway and the sensitive backend network. It delivers various solutions on one central platform with a flexible deployment, grow as you go. And most importantly, it is based on Safe-T's patented reverse access technology. Safe-T's patented reverse access technology removes the need to open any ports within a firewall while allowing secure application access between networks. The role of the access gateway is to act as a front end to all services and applications. It operates without the need to open any ports within the firewall, therefore ensuring that only legitimate session data can pass through it. It performs TCP offloading, allowing it to support any TCP-based application without the need to decrypt the network traffic. The role of the access controller is to pull the session data into the internal network from access gateway, and only if the session is legitimate, pull it and pass it to the destination application server. As a response is sent back to access controller, it is relayed all the way back to the user. Let's start diving deeper into ZoneZero and start with its approach to SDP. ZoneZero SDP is built from the ground up with overcoming current challenges in mind. It is based on Safe-T's patented reverse access technology, separates the authentication layer from the access layer, provides native support to legacy applications and protocols, and is designed to work in parallel with existing technologies that organizations use. To make for an easy deployment and quick adoption, it is also completely clientless and agentless, and can be deployed both as a hybrid cloud service or as a complete on-premise solution. When deployed on-premise, ZoneZero SDP is composed of 3 servers. The solution is deployed in multiple tiers within the organization and the public cloud. The cloud tier includes the authentication gateway, which is deployed in a cloud location, such as AWS or Azure. The DMZ tier includes the access gateway, designed to control which pre-authenticated inbound traffic to accept, while denying everything else. And the LAN tier, which includes the access controller that connects to the organization's backend applications, storages, and authentication services. When consumed as a hybrid cloud service, ZoneZero SDP is delivered in a 2-tier architecture. The ZoneZero SDP Cloud tier hosts both the authentication gateway and access gateway, separated in 2 different instances. The LAN tier, which includes the access controller, is hosted on-premise, behind a closed-at-all-time firewall, and holds the business logic and decision-making processes. ZoneZero SDP is the first flavor of zero trust that the ZoneZero platform provides. The second piece is ZoneZero VPN. Chief Information Security Officers are seeing existing solutions as constraints in implementing SDP and achieving zero trust. This is because traditional SDPs struggle with legacy applications, infrastructures, and operating systems that are not zero trust aware. Those SDP deployment models are not scale-ready for large organizations. The result until now has been very low adoption rate for SDP solutions and a hurdle in walking the zero trust path. ZoneZero VPN allows you to achieve your zero trust goals on your legacy environment, bringing the benefits of SDP into your existing VPN infrastructure. It separates the control plane from the data plane, enhances authentication by introducing MFA, and provides resource or application-based access control policy. It is designed from the ground up to be simple, easy, and non-intrusive to deploy, and it is therefore vendor agnostic and implements seamlessly with no changes to either users or resources. Let's take a look at how ZoneZero VPN is implemented and integrated with an existing environment. Using a virtual wire deployment, ZoneZero is easily set up in the DMZ network, immediately separating the front end and VPN gateway from the back-end firewall in any sensitive environment. The ZoneZero virtual host includes a virtual switch and 2 separate subnets, which provides true separation of modules. To finalize the deployment, we connect the ZoneZero access gateway to the VPN front end and the access controller to the back-end environment using 2 separate subnets. ZoneZero integrates directly with the VPN and discovers any new connections. It then pulls user information, including mobile phone numbers, from the identity source such as Active Directory, and then enforces MFA on a separate back channel using an API such as Telegram that is triggered by network requests. ZoneZero VPN magically transforms your existing VPN into a zero-trust secure access solution with hardly any effort. The benefits are threefold. From an operational standpoint, it supports any authentication method using APIs. It is transparent to users and don't require changes to endpoints. It's very quick to implement, and your existing access policy management remains as is. From a security standpoint, it transforms your VPN to a layer 3-4 appliance and isolates VPN connections from the network, therefore reducing vulnerability scope. It enforces a least privilege authenticate first, access later flow and provides access policy enforcements on application or resource levels. It requires no open ports into the back end of the organization and integrates, instead of replace, existing security infrastructure in a fully compatible way. Finally, it brings support for REST API-based MFA and all the benefits of traditional SDP. The final pillar of ZoneZero and the road to a complete zero-trust environment is multi-factor authentication. Everyone recognizes the crucialness of MFA, but with the existing technologies, it's virtually impossible to embrace it enterprise-wide. Identity providers and other MFA solutions are separate entities providing these services. However, if your application is not web-based, implementing it may prove more unpractical or very difficult. And if you wanted to introduce MFA to your proprietary applications, the integration requires the use of an overwhelming number of APIs in the application code, and varies by platform. Furthermore, if we consider legacy protocols and applications that do not natively support MFA, it quickly turns from a challenge to an impossibility and is excluded from the MFA strategy. ZoneZero MFA allows you to easily apply MFA not only to external users and services, but also for any application or resource on your network. It once again separates the authentication layer from the access layer, as it authenticates on a back channel without relying on the actual application or resource. It is vendor agnostic to your infrastructure and supports any type of service or application, whether they natively support MFA or not. You can enable MFA to things like SMB shares, RDP connections, VMware and VDI, and essentially anything else. It is a seamless central deployment and doesn't require any changes to the client side for users. By utilizing ZoneZero MFA, you immediately embrace another key element of Zero Trust, which is oftentimes forgotten: continuous authentication. In spite of originating from a pre-authenticated session, such as an in-office access or an existing VPN connection, access is not considered trusted, and sensitive resources can continuously re-authenticate to ensure a legitimate user is in fact the one using the pre-existing session. This eliminates identity takeover frauds without affecting the user experience. The ZoneZero MFA solution is deployed in a very similar way to ZoneZero VPN, with the difference only lying in the integration to a central backend firewall instead or in addition to the VPN service. ZoneZero bridges all the gaps and overcomes all the challenges organizations face in adopting an enterprise-wide zero trust strategy. It revolutionizes SDP, VPN access, and multi-factor authentication in one central unified platform which deploys quickly and easily, seamlessly transforming your existing infrastructure to a zero-trust environment. Thank you for watching. We look forward to help you on your path to zero trust the right way.